All right. Good evening, everybody. So my name is Derek Z, and tonight I'll be giving a tool talk on Sigma correlations. So first off, right off the bat, some of you might be wondering, what is Sigma? If you spend enough time on the internet, you know you're probably in that Sigma grind set these days. So whatever that means to you, that's not what we're going to talk about tonight. I'm not going to teach you how to be the Sigma male or the Sigma female in your friend group, peer group, adversary group. Those are not what we're going to talk about tonight. What we are going to talk about is Sigma as a Swiss Army knife for SIEM queries, or security information and event management products and platforms. The general idea behind Sigma is to act kind of like that catch-all way of writing detections, just like how Yara, or yet another ridiculous acronym, is used for files, or Snort and Suricata is used for network traffic. That's the same idea and concept behind Sigma. You write one rule that can be translated to multiple different platforms, sort of. And I'll explain a little bit why I say sort of later. But that's it. You write one rule, it's platform agnostic, and you can share it with the community. It makes sharing detections very easy, because if I were just to take a quick poll of the room, how many here, if you can admit it, use Splunk at work for your SIM? We got one. How many here use XSIAM, or whatever Palo Alto calls it these days? 0. How many people use Kusto or Sentinel? There's a couple of you. You get what I'm going at here. Nobody here is working on exactly the same platforms. So that's what this is useful for. So what does a Sigma rule look like? During this talk tonight, I'm not going to get into how to write a good Sigma rule. You can talk to me after this, because writing a good Sigma rule is like painting art. It's very subjective, and everybody paints differently. So I can say, hey, go check out the specifications, but that doesn't mean you'll write a good Sigma rule. What I am going to do is just highlight some of the key features that have to be in a Sigma rule. So it might be a little small on the screen, but for those of you that can see the screen, there are a couple of lines that are highlighted in bold. Specifically, those lines are required, and those lines are the title of your rule, the detection portion where you're trying to go, this is what I'm looking for, this is what I'm going to query for in my environment, and then what is the true or false result of that? I'm looking for something that matches this result. That's it. That's a Sigma rule in a nutshell. There are a lot of other fields that you can throw in there, such as metadata on what attack technique this falls under, or tactic, your references, when was the last time you updated this. There's so many more. And again, you can go and read that in the manual. But this is the general idea of a Sigma rule. So correlations were a relatively new feature, because they did in the past try to do something similar to this, in which they had a piped output for Sigma rules. And it wasn't working super great, mostly because there wasn't a lot of support for doing that. And a lot of the burden was on specific communities for writing the backends for these Sigma rules as they get translated to those different platforms. So the folks behind Sigma said, you know what, let's redo it. We already have the single rule matching feature enabled. Let's write it in a similar way to where essentially you're just adding on new features to something you've already written, and you don't have to rewrite the whole thing. So it was actually introduced early, I think it was in beta testing early of 2024, formally introduced to the larger community in June of 2024, and at the same time was introduced in the command line interface for Sigma, which is Sigma CLI or PySigma. It was compatible with two backends, which is Splunk and Elasticsearch Query Language. I don't remember what all the new ones are. We can do that in a little bit. I did set up a live demo in about 30 minutes ago, so we'll see how well that works. But again, the general idea of correlations is you have a single query that you want to look for multiple times. You want multiple results instead of just looking one query at a time. So with that, there are 4 types of correlations with with Sigma correlations. The first one is event count. And literally, you are just counting something that matches. A good example of this would be failed logons in a Windows machine. So some of you might know Windows security event 4625 is failed to log on to a service. If you saw a lot of those in a short period of time, that might be something you'd be suspicious about. With the general rule, you would only capture all of those events without any type of aggregation. With the correlation of event counts, you can now give it some criteria. So for example, you're looking for 10 or more failed logons in a 5-minute bucket. That's something you can do with this type of correlation. Second one is value count, and you might recognize this image up here. Value count is looking more so, it's similar to event count, but it's looking for distinct values inside fields. So let's say, going back to the failed logon example, let's say you're looking for unique usernames in the user ID field. This is what you could use that for. If you see somebody is trying to log on as a bunch of different distinct users, you might be seeing a password spray attack. And that's what this correlation can help you to do. Again, 5 minutes, you're looking for something less than, you're looking for a lot of distinct counts without having to run the query multiple times or trying to parse it manually yourself. Next one is temporal. So this is where you start to have a little bit of fun, and it starts to go outside of just, I'm looking for X event. Now, you're looking for a certain number of events that happen close to each other. So for example, we have failed logons from earlier. What if you had a bunch of failed logons and then 10 minutes later you have a successful logon? That could be somebody who finally figured out the password to an account and has now logged onto that machine and is in the steps of compromising that machine. That's where temporal comes in. One thing to note about this is when you set your time frame, it's looking for all the rules you are trying to match on within that same time frame. So for example, Windows failed logon. There is a rule for that already in the Sigma headquarters GitHub repository. In addition, there's a successful logon. So again, Windows security event ID 4624. If I saw a bunch of 4625 and then in that same time bucket, I saw a successful logon, that might be something worth checking out. That's where temporal comes in. And finally, ordered temporal, which is the trickiest of the bunch. And the reason for that is because it's looking for things happening in a specific order of operations. A good example for this one is host enumeration. When somebody logs onto a new box, let's say you're at the Cyber Defense Challenge at Iowa State, what's like the first 3 things that you do? Who am I? Maybe netstat, maybe IP, and then maybe looking for some other information on what files you have. If you have like a good cyber threat intelligence shop and goes, this is the exact order of operations that this threat actor does on a device as soon as they log on, that is a great way to capture them. However, the tricky part is if that changes, or if you have timing issues because nobody has ever had skewed time on a machine before, that can alter your result from this. So it's not recommended to use this right off the bat, but if you absolutely know what you're doing and you know absolutely what you're looking for, this can be an extremely powerful tool. So, just to give you an idea, I went through the GitHub repository for the Sigma rules that are out there in the community and found one on behalf of, I don't think Trevor is here right now, I can't see him. He's in the back. So Trevor, if you didn't know, his handle is about Kerberoasting. So in honor of that and him helping us almost win the KernelCon CTF, I said, hey, well, if we have Kerberoasting, you don't just do it once and get success, you have to do it a couple times. So what if we took a rule about looking for Kerber roasting and taking the author's notes of, hey, this needs further analysis, I want to look at it in 5-minute periods, and I want to set a threshold. What if we took that rule, converted it through the black box of correlation, and we come out with an incredibly simple sigma correlation rule, where all I literally did, and I don't know if this actually works. Again, I wrote this about 30 minutes ago, so do not come at me if it doesn't work. This is the general idea of, I already have a rule, I just added something on top of it, and now it can look through multiple events instead of one event. That's it. It's that simple. Again, the hard part is knowing, while you have this canvas, is knowing what to paint on the canvas. But the tools are really simple to use. So what are those tools out there? So Sigma headquarters is a great resource. You can go to their main page. I'll actually pull it up here in a second. They also have a GitHub repository where you can pull a lot of stuff. They push out releases pretty frequently. I want to say it's every 2 months or so. They have a blog to where you can find all the same exact information. And then finally, one of the courses that really helped me in getting better, not great, better, I would say above average than some other analysts and thrunters out there, is the Applied Network Defense course for detection engineering with Sigma. Oh yeah, so that is my last slide. So it might help if I remember where I put things. So just to show you where those are, here's the web page. This is Sigma headquarters. You have your own docs to read. This is the GitHub repo. And since I brought up thrunting, this is one I wanted to highlight because you can use those Sigma rules to help out the, I believe it's Hunting Exchange and Research Threat Hub, or HERTH. And so this is a shared community to where they share ideas about different types of threat hunts you can perform based upon Splunk's peak thrunting framework. And so there's a lot of really neat ideas of where you can start to take those rules together and apply them to some of these hypotheses, some of these ideas, and then contributing back to the community. So again, wrote this very quickly just to give you an idea of how simple it can be. As soon as I remember how to make the text a little bit bigger. It's big enough. All right, so in my Sigma grind folder, I have some rules, and this is straight from the repository. And then I started one called correlations. And so in here, I wrote that exact same thing that you saw up there. So just to give you an idea, that's literally the exact same thing you saw on the slides. And it has has a little bit more than the essentials in there. And you'll see, I did already write this out, so you don't have to see me fail too much. But it is that simple. Now, the problem is, let's say somebody give me a backend or a SIM platform. I don't think Sumo Logic is actually available as a plugin. Elastic? Yeah, we can do Elastic. So let me remember let me just remember what is it actually called, because there are different specific names, and I'm sorry if I'm going a little fast. So we do have Elasticsearch, and that does include Elasticsearch Query Language, Elastic Query Language, and DSL, which I cannot remember off the top of my head right now. But it's very similar to Kibana. So if I go in here, and I think we'll just do EQL for now. And I try to convert it, hey, I need a pipeline. You might need this from time and every now and again. It basically just needs to know how to map those fields. So let's see, what pipeline do I need? And I'm doing this in the most inefficient way because I'm trying to vamp for as much time as possible. How am I doing on that, by the way? It's been 14-ish minutes, so I'm doing pretty good for vamping. There we go. So I probably need this one right here. You can't see me highlight it until right now. I probably need that, which is the mapping for Elastic Common Schema for Windows. Oh yeah, there it is. If only I looked down a little bit and learned how to read. So once again, I'm converting this rule with this pipeline in the correlation language. Oh, darn, it's not available as a feature in that specific language. So that was actually, I'm glad that you said that, because that's one of the things is a lot of these backends are still getting updated. So not all of them have this available, but you probably are going to find that your backend has the support that you need. So with that, I'll open up the floor to any questions. Again, knowing I am not a master wizard of writing Sigma rules, we can talk about that all night if you wish. But for any questions over correlation specifically for Sigma. Going once, going twice. Yes, sir, in the back. The question was, do I have a favorite lab environment? Yes, I prefer the terminal. However, there actually has been somebody who stood up something web-based recently and makes it a lot nicer and cleaner to look at, called detection.studio. And it does all the same stuff. It's literally that same program I was running from the terminal as a website. That's it. The nice thing, though, is I don't have to go out and look for new rules. They're already in here. So it can immediately give me a template and a template for correlation rules. Let me see if I can, there we go. Make that a little bit. And then in this browser area, it is a little slow because I'm on their Wi-Fi. It feels slower because I got that Google Fiber 1G up and down, so it starts to notice. But anyways, we could pick any one of these. The rule is right there without having to go to the GitHub repo, without having to unzip everything that's in there, looking for that exact thing. It's all in one site for you. So I would say this is starting to become my new favorite way of writing out these rules and doing that research. Does that answer your question? Perfect. All right, that was an excellent question, and I think that was 17 minutes, which is 3 over what I said I could do. So with that, appreciate your time, everybody. We'll get the next talk set up soon.